Let me explain about the covalent bond and its various types. Take down covalent bond. Covalent bond is formed due to mutual sharing of electrons. Between two atoms. For example, let us consider hydrogen. Hydrogen has one electron and this hydrogen has one electron. So they mutually share to form a bond, that is H bond. It is a single covalent bond. Similarly, chlorine, it has an electron and this chlorine has an electron, so they may result a bond. So Cl bond, that results chlorine molecule, Cl2 molecule. In fact, the hydrogen has got only one electron, so this also has one electron, so they can have mutual sharing of electrons to form covalent bond. And what about this chlorine? It has more than one electron, but when you look at the atomic number of chlorine, it is 17. So in the first shell 1s2, you have in the s orbital 2 electrons, 1s2, and in the second shell 2s2, 2p6. That is, in the first shell you have 2 electrons, in the second shell you have 8 electrons, and third shell, so 3s2, 2, 4, 10, 12, and 3p5. So in the third shell you have 7 electrons. Usually the electrons are arranged in the order 1, 2, 3, 4, 5, likewise. And these are all called the shell, okay, the main energy level. Okay, you can call it shell. And you have subshells also, subshells, and they are called orbitals. And this shell can also be called orbit or energy level. So in the first shell you have s orbital, in the second shell you have s and p orbital, in the third shell you have s, p, d, in the fourth shell you have s, p, d, f, likewise. Okay. So the s orbital can have maximum 2 electrons. P orbital can have maximum 6 electrons. D orbital can have maximum 10 electrons. F orbital can have maximum 14 electrons. So something like a 4-track system in the highways. So you have some main energy level, and in each you can find various subshells. In the first shell it can have S, in the second S and P, in the third S, P, D, in the fourth S, P, D, F, like that. So when we write the electronic configuration, and you must ensure that these orbits and orbitals are filled up. And in fact, s orbital can be represented by a single box, so it can have maximum 2 electrons. P orbital can be represented as a triple box, so it can have maximum 6 electrons, so 2 in each box. and the d orbital can be represented in the 5 box 1, 2, 3, 4, 5. So each one can have 2 electrons, so maximum 5 electrons. So likewise you have in f orbital also that has 14. In fact, this is beyond your scope, but even then you try to understand this. So you have chlorine here 17. So in the first shell you have to put 1s2, second shell you have to put s and p. So 2s2, 2p6. Third shell you can have 3s2, 3p5, 3d, but the available electrons are 17. So you have to stop with that. So 2 plus 4 plus 6, 10, 12, 17. That's all. Beyond that it will be 0 only. That is, you will be having vacant orbitals. So you have to consider the outermost shell only when you consider the valency. Valency means a binding tendency, that is the number of electrons available in the outermost shell. So as far as chlorine is concerned, the outermost shell is third shell. In the third shell, how many electrons are there? Totally 7 electrons. So there is a rule called octet rule. According to octet rule, to attain the stability, the electron system, the atomic system should have 8 electron system, and they are stable. So every element will try to attain, that is obtain this 8 electron system, that is octa means 8. So by taking 1 electron, this chlorine will become easily 8. In the case of metals, by giving out electron, they become stable. Now we have this chlorine, and the chlorine here you can write this. We have got 2 chlorines, is it not? So chlorine, and we need a bond between them. So let us represent it by, for the left chlorine dot, for the right chlorine cross mark, just to represent the electrons. So each should have 7. So the 7th one is given here. So what about the remaining 6? So 1, 2, 3. So 6. Similarly 1, 2, 3. Are you able to follow? So this is the way you have to draw the Lewis dot structure. And you can now, because I already suggested, the elements should have 8 electron system so that it will have better stability. So in order to have better stability, now 2, 4, 6, 7, and it includes 8 also, so that is why it shares. And similarly you can count 2, 4, 6, 7 and 8 also. So this represents what? A covalent bond. Are you able to follow? And that is why they mutually share, and each of them can attain 8 electron system. Say they attain the stability. Are you able to understand? So this is the way you have to establish the bond between 2 atoms, and here it is simply represented as Cl, Cl. That's all. Cl bond Cl. Are you able to follow? And what about these? These are all non-bonding electrons. They are not involved in the bonding, but they are available for what? As lone pairs. So this is regarding chlorine-chlorine bond. Then let us move to the double bond, like in the case of oxygen. Let us consider oxygen, O2 molecule. For oxygen you have, that is O double bond O. What about the electronic configuration of oxygen? For oxygen it is how much? 8, is it not? What is the atomic number of oxygen? 8. So 1s2, 2s2, 2p, how much? 4. Are you able to follow? Now the second shell is the outermost shell as far as oxygen is concerned. So 2 plus 4, 6. So by taking 2 electrons, it will achieve the stability. Are you able to follow? And thereby the valency will be 2. Now you have oxygen here, another oxygen is here, and 2 electrons are given here, 2 electrons are given here for bonding. And what about the remaining? The remaining total is 2 plus 4, 6. So 2 have been donated, so remaining 4. So the 4 will be like this as non-bonding or lone pair of electrons. Okay. Now you can account for the 8 electron system. How you can do that? That is 2, 4, 6, and you can include this one also. See that? So are you able to get 8 electron? And this also. When you count, you can have 8 electron. So both of them are stable, and thereby they have the what? You can link these two. See that? So it forms a double bond. Got it? So this can be simply represented as O double bond O. If you want to put the electron dot, you can have the electron dot. Okay, with the 2 lone pairs of electron on each oxygen. So do you understand? Let us draw this is called double covalent bond. Let us consider any alkene. In this case, let us consider alkene, ethene. Example, ethene. What is the formula? C2H4. So C double bond C H H. So this is the double covalent bond. Let us illustrate the structure for this. So you have C electron, C, and 1 electron, and 1 is hydrogen, 1 is for hydrogen. And similarly for hydrogen, for hydrogen. Okay, you can link this. Now as far as hydrogen is concerned, you have 2. 2 is also stable. For hydrogen it is 2 stable, and for this hydrogen it is stable, and 2 stable. And what about this carbon 2? You have to include 2, 2, 4, 6, 8. So you have to combine everything. Are you able to follow? Okay. So here 2 electrons, 2 electrons, 2 electrons, 2 electrons. And what about carbon? 8 electrons. Now we have to check for chlorine. Okay, let us check chlorine. 2, 4, 6, 8. So it will be like this. It will combine like this. Okay. Actually I am talking about C, not chlorine. C. So this too has 4 electrons here. Okay, so this is C2H4, and this is also having 8 electrons. So overall the structure is stable, and this is called Lewis electron dot structure. Okay. We can draw similarly for methane and ethane also. Let us draw for methane. CH4. So you have carbon, and what is the valency of carbon? 4. So you have 1, 2, 3, 4. What is the valency of hydrogen? 1. So you can mention this as H, 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 H. Now for each hydrogen you have 2, 2, 2, 2. Is it not? And for carbon you can take 2, 4, 6, 8 together. Okay, so you can draw the structure in this way also. That is C, and one is shared by carbon, another is shared by hydrogen. One is given by carbon, another is shared by hydrogen. One is given by carbon, another is hydrogen. One is given by carbon, another is hydrogen. So you can draw in this way also. Are you able to follow? So you have, okay, so each has 2, and overall carbon is 8. So this is 8 electron, this is 2 electron, this is 2 electron, 2 electron stable system. So similarly here 2 electron, 2 electron, 2 electrons, 2 electrons, and at the center you have 8 electron system. Do you understand? This is the case with methane. So here you can show the bond also clearly. For example, CH bond, CH bond, CH bond, CH bond. Okay. Here you have to consider this as a bond, because for a bond 2 electrons are required. And then for ethane, let us try. Ethane, what is the molecular formula? C2H6. So you can put 2 carbon atom. Okay, and in between that you have, for example, for each carbon you should have 4 valency. So let me indicate by this. I am just distinguishing the type of electron as dot and cross to distinguish the 2 sets of electrons. Okay. And what about hydrogen? So you can mention hydrogen here. Hydrogen, hydrogen, hydrogen. Similarly, hydrogen, hydrogen, hydrogen. Right. Now we can form a bond. See, this is CC bond. This is CH bond, CH bond, CH bond, CH bond, CH bond, CH bond. Now we have to check the electron system whether the octet rule is followed or not. Listen here. When I teach you, you please follow me very carefully. Then you have 2 electrons. This hydrogen has got 2 electrons. This hydrogen has got 2 electrons. Similarly, you have 2 electron and you have 2 electron. This one has 2 electron. So all these hydrogens have 2 electrons, so it is stable. And what about carbon? We'll check whether it has 8 electron system. 2, 4, 6, you can include this one also. So are you able to understand this drawing? So it has included 2, 4, 6, 8. Okay. So this carbon has 8 electron system. And what about this? You have to include like this. You have to include here only this much. Forget about this. You have to include only the shared bond. Okay. So likewise, it can also have 8 electron system. So 2, 4, 6, 8. Okay. And this can also be drawn in this way. Carbon, bond, carbon, and here bond, so hydrogen, 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 hydrogen. Now you can link it. So here for hydrogen 2, this hydrogen 2, this hydrogen 2, and this hydrogen 2, this hydrogen 2, this hydrogen 2. And what about carbon? You have to include carbon like this. Are you able to follow? Similarly, this carbon. Got it? So this is 2 electron, 2 electron, 2 electron, 2 electron, 2 electron, 2 electron. And what about carbon? This carbon is 8 electron, this carbon also 8 electron. So it is completely stable, satisfies the Lewis dot structure. Okay. So this is ethane. Let us try nitrogen, triple bond. N2. Nitrogen has the atomic number 7. So 1s2, 2s2 and 2p3. 1s2, 2s2, 2p3. So you have one s2, 2s2, 2p3. So in this case, in the second shell, you have 2 plus 3, that is 5 electrons, where 2 electrons are called lone pair of electrons. Lone pair of electrons. And they are also called non-bonding electrons. They don't involve in bonding. Okay. Electrons, they are called non-bonding electrons. They don't involve in bonding. Whereas bonding electrons, that is valency electrons, this one. Okay, the 3. And let us have nitrogen. Nitrogen, they involve in bonding like this. 3, 3, because there are 2 nitrogen. And the leftover is a pair of electron, one lone pair of electron is left over. So it will form a bond like this. 1, 2, 3. So it's a triple bond, and that is why nitrogen has a structure triple bond like this with a lone pair of electrons on each side. And we can represent this by the overlapping of these orbitals. So here nitrogen 2 plus 3 plus 5, 8. So 8 electron system. Similarly 8 electron system. Are you able to follow? So this is the case with nitrogen. Let us check ethane, which is alkyne. Ethane means C2H2. So in this case, the carbon will have a triple bond. So C triple bond CH. This is the structure. But let us work on the Lewis structure. So C for a triple bond 1, 2, 3, and for this carbon 3. So C, and here that is 1 and hydrogen. Here that is 1 and hydrogen. Okay. Now it forms a triple bond. Are you able to follow? And similarly, see, this forms CH bond. So the CH, this hydrogen has 2 electron system. This hydrogen has got 2 electron system. And what about this carbon? This carbon has 8 electron system. Are you able to follow? And what about this? Got it? 8 electron system. So this is stable, right? So it has got linear structure. We can work on the water molecule also. Let us work out on water molecule H2O. So H2O actually it has got bent structure like this. Okay. And what about oxygen? Oxygen has got atomic number 8. So 1s2, 2s2, 2p4. Is it not so? What about the box model? 1s2 box model, and this is 2s2, and this is 2p4. 1, 2, 3, 4. So it means we have 6 electrons. We have to account for 6 electrons. 2 electrons are bound with the hydrogen. So oxygen is there. 2 electrons are bound, and the remaining 2, is it not? We have got 2 sets of electrons. Okay. And 2 pairs unpaired, lone pair of electrons. So here you have lone pair of electrons. This can be represented like this also to indicate they are non-bonding or lone pair. So this is called lone pair of electrons. Lone pairs of electrons. So these 2. And what about oxygen? It will combine with the hydrogen to form OH bond. Similarly, OH bond. Now, as far as hydrogen is concerned, you have 2 electron system. This hydrogen, you have 2 electron system. And what about oxygen? 2, 4, 6, 8. So you have to combine everything. So for oxygen, you can combine like this. So 8 electron system is stable. So likewise, every time you have to check the stability and draw the structure accordingly. Similarly, we can draw ammonia, NH3. So nitrogen is at the center and it has got the tetrahedral structure like this. Okay, this is ammonia. There are 3 NH bond. Now let us talk about the nitrogen. It is 7. So 1s2, 2s2, 2p3. It means you have 1s2, 2s2, 2p3 means 3 boxes. 1, 2, 3. Okay, so all these arrow marks represent the electrons. So we have 2 plus 3, that is 5 electrons. So here 2, so a lone pair is assigned here. So remaining 3 can combine with the hydrogen. So we can draw like this: nitrogen 1, 2, 3, and you have one lone pair of electron. So here you have hydrogen, hydrogen, hydrogen. So they have paired like this. Now you can draw NH bond, NH bond, NH bond, or you will see, and this is 2E system, stable, 2E system, stable, 2E system, stable. And what about nitrogen? You have to include everything and check the number of electrons: 2, 4, 6, 8. So this is 8 electron system. So this is the way you have to draw the structure. So these are all called Lewis dot structures that explain the stability of the molecules also.